Hello friends, this is a solution video for question number 24, chapter 6, HC Verma. The problem statement says, the friction coefficient between the two blocks shown in figure is mu, but the floor is smooth. A. What maximum horizontal force F can be applied without disturbing the equilibrium of the system? B. Suppose the horizontal force applied is double of that found in part A. Find the acceleration of the two masses. So in this problem, there are two blocks placed one above the other. The mass of this upper block is small m. The mass of this block is capital M. Let's say this is block A and this is block B. In the first situation, we have to find the maximum force which can be applied on block A so that the equilibrium is not disturbed. So once the force is applied on the upper block, there will be a tension T generated in the string. Let's say this is T. This is the same string, so tension T will also be here. In the influence of this force F, the block A will try to move in the left hand direction. So that means there will be a frictional force between the surface of A and B. So let's say this is Fr. The coefficient of friction between the surface and this block B is 0. So that means there is no friction between the B and surface, right? Now, with the help of free body diagram, we'll try to find out the value of F. Okay, so for case 1, FBD of block A. So this is the block A. The mg force will act downward. The reaction forces are in upward direction. The tension T in the string in the right hand direction. The force is applied in the left hand direction. This block will try to move in the left hand direction, so there will be a frictional force F R in the right hand direction. Okay. Now, from the vertical forces, R is equal to mg, right? We know that frictional force is given as mu times R. So that means Fr will become mu times mg, right? From the horizontal forces, F minus T minus Fr is equal to 0 because the acceleration of this block is 0. Since they stay at rest, so that means acceleration is 0, right? So this will become F is equal to T plus Fr. I'm putting the value of Fr as mu mg, so this will become mu times mg. Let's say this is equation 1. Now, the FBD of block B. So this is the block B. The tension in the string will try to pull this in right hand direction. There will be a frictional force between A and B. Now this time this block will try to move in the right hand direction. So the frictional force will act in the left hand direction, and that is Fr, right? The total mass M plus mg will act in the downward direction, and the reaction force is in the upward direction. Okay. Now, from the horizontal forces, T minus Fr is equal to 0 because the acceleration is 0, right? So that means T will become Fr, or Fr value is mu times mg, right? So we got the value of T as mu times mg. Putting this value of T in equation 1, we will get F is equal to mu mg plus mu mg. That means 2 times mu mg, right? So this is the maximum force which can be applied on block A, conditional the equilibrium of these two blocks will remain same or they stay at rest. Fine. Now for case 2, in case 2, the force applied on this block is doubled, right? And it is saying that the force is doubled which is coming from the case 1. So that means this force is doubled on block A, right? So now this time, so let's say what is the FBD of block A? So this is the block. This time the force is twice. The tension T will remain same T. The frictional force Fr, the mg force downward, and the reaction force upward. This time the vertical forces will remain same. So that means the value of Fr will remain same as mu times mg. The only change is in the horizontal forces, which is twice of F now. Now putting the value of 2F minus T minus Fr is equal to, let's say this time this block will move in the left hand direction with an acceleration of A. So this will become m times A. Now putting the value of F as 2 mu mg and the value of Fr as mu mg, we will get 4 times mu mg minus T minus Fr is mu mg is equal to ma, right? Now similarly, FBD of block B. For this time, this is the block B. The tension T is in the right hand direction and the frictional force is Fr. The m plus mg force will act downward direction and the reaction force in upward direction. So from here we will get T minus Fr is equal to m times A. Now that means T is equal to m times A plus Fr. The value of Fr is mu times mg. So this will become capital Ma plus mu mg, right? Now putting the value of T in equation, say this is 2. So this will become 4 times mu mg minus Ma plus mu mg minus mu mg is equal to Ma, right? So after solving this, we will get 4 mu mg minus Ma. So this is minus mu mg is 2 mu mg, right? So this will 2 mu mg is equal to Ma. So the acceleration in this case will become, acceleration is equal to 2 mu mg upon m plus m. So in the second case, when the 2F force is applied, the acceleration of these blocks will be 2 mu mg upon m plus m. So this is the solution of this problem.